This lesson is on dividing powers. So it has to do with multiplying and working with exponents again, but instead of multiplying and adding the exponents, we're going to be dividing and subtracting the exponents to find the answer. Okay? Take a look at this first example. Well, first of all, before we start, this is really important, so I'll highlight this in your notes. Any number to the 0 power is 1. Okay? Whether it's a variable like a to the 0 power, or if it's a number like 5 to the 0 power, anything to the 0 power is equal to 1. So I'll highlight that. And then look at this example. A to the 4th power up on top, and a to the 6th power in the denominator. And when you write that out in expanded form, it's a times a times a times a on the top line, and then a times a times a times a times a times a on the bottom line. And each one of these pairs is a reciprocal. It's the same number divided by itself. A divided by a is 1. 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 So all of those become 1. And how many a's are left on the top line? 0. So it's literally a to the 0 power on the top line. That's where that concept comes from. Anything to the 0 power is 1. So there's literally 0 a's left, and that's why we're left with 1 up on the top line. There's 2 a's left on the bottom line. So it's 1 over a squared. Okay? Now, there's another way to write 1 over a squared. Without the division bar, you'd write it as a to the 4th power minus 6, because we're subtracting the a's. Whenever you're dividing, you're subtracting the exponents. And we end up with a to the negative 2 when you subtract those. 4 minus 6, or 4 plus negative 6, equals negative 2. So these two, a to the negative 2 power, a to the negative 2nd power, and 1 over a to the 2nd power are totally equal. Totally equal. A to the negative 2nd power and 1 over a to the 2nd power are equal. So that means that if we wrote this a to the negative 2nd power and put the a on the bottom line, it changes from a negative exponent to a positive exponent, doesn't it? It becomes, the 2nd power becomes positive when you move it to the other side of the division bar. And that's the point that's down here. So make sure you have that in your notes. Look at this. A to the 3rd over a to the 3rd. All the a's cancel out, and it's a to the 0 power or just 1. Okay? N to the negative 3rd power can be written as 1 over n to the positive 3rd power. So again, anytime you have the negative power, if you move it to the other side of the division bar, so if it was on the top line, you move it to the bottom line, it becomes its opposite. If it was negative, it becomes positive. If it was positive on the bottom, or in the denominator, it becomes negative if you move it up to the top line. Okay? And that's what this is talking about. If you move a power from the top to the other side of the division bar, so from negative n to the negative 3rd over to the denominator, it changes from positive to negative, or negative to positive. It's the opposite of what it started with. Okay? Let's go through some examples on your worksheet. The best way to get this is just to practice these. So the first one, we did it in your notes. That was 7 to the 8 minus 2, which is just 7 to the 6th power. Jen?
Why would it still be 7? Because you're dividing it, aren't you?
Yep, we're dividing it, but when it's, there's still six sevens left over on the top line. If we were to write that out and we put 8 sevens in the top line and 2 sevens in the bottom line, we'd have two pairs that would cross out, or 2 of them that are reciprocals of each other that just become 1. So then there's would be 6 of them still left over on this line. Okay? Like this. If we were to write this out, x to the 5th power over x to the 1st power, there's one pair that's a reciprocal that we can cross out, and then that leaves 1 in the denominator, and what's left over is x to the 4th over 1, or just x to the 4th. Okay? 5 to the 0 power. Tyler? 1. N to the negative 3rd power. What is that, Carson? It's 1 over n to the 3rd power. That one was in your notes. So if we move this from the top of the division bar, whenever it's written without a division sign, this is just assuming the top line of the division bar. And then if we move it to the bottom side of the division bar, the exponent becomes positive. And we write the 1 on top. Okay? Yeah, it's kind of like flipping it. Yep. Yep. Just wait. Yes?
Can you put it over 1? Like
It would still be technically correct, but you don't write whole numbers over 1 usually. You know, if you're writing it just a number 5, you usually don't write it as 5 over 1. You can, yep, and sometimes you have to, but it's just, it wouldn't be wrong. No, there's just, you can if you want to on these, especially when you're simplifying it like a fraction. I would accept it. All right. How can we write number 5 with only positive exponents? There's 1 with a negative exponent, and so if we move that to the bottom line, the y to the 4th power stays on the top line, and the x to the negative 2nd power becomes positive when you move it to the other side. Okay?
Yeah.
The x to the 2nd power, or x to the negative 2nd power, when you move it to the bottom side of the division bar, you move it down and it becomes positive. Okay? There's just one step. It's just to move the x to the negative 2nd power to the bottom of the division bar.
And then change it
to positive. And the y to the 4th power stays positive. Okay? Number 6. What part is being taken to the negative 3rd power?
A.
It's just a, right? So the a moves to the bottom side of the division bar. I'll write that using this bar right here. A to the 3rd power, and the 6 stays above it. Okay? Anything to the 0 power is 1. So number 7 is 1.
So number 12.
Number 8. If there's 3 b's on the top line and 8 on the bottom line, how would we simplify that?
5B.
There's 3 pairs that are reciprocals that cross cross out. So what's left?
B.
On the top line or the bottom line? On the bottom. So it's 1 over b to the 5th power. Does that make sense?
Wait, what's number 10? Can we do number 10 together?
Sure.
Because there's two negatives.
Yep. So both of them move to the bottom line. S to the 5th and t to the 3rd over 7.
Okay, got it.
It was s to the negative 5th power, and so we moved it to the bottom, to the denominator side of the division bar, of the fraction bar. When we move it to the bottom side of the fraction bar, the negative exponent becomes positive. So it goes from negative 5 to positive 5, negative 3 to positive 3.
Where's the 5?
What 5?
The big 5. Yeah, that's
There was no big 5. There's a big 7.
yeah.
That stays on the top
It's not on
line.
the bottom line.
On the bottom line, there's an s to the 5th power.
Oh, S. Looks like 5.
No, it's an s.
Okay.
10.
Would you do number 14? Would you put the 4 and e to the 3rd power on top?
Yeah, the 4 and the e, because they're all positive, stays on the top line. And then the f to the negative 2nd power goes to the bottom line.
Oh, okay. I'm trying to understand what you're saying.
Yeah.
Very small.
How about number 9? How would you simplify 9?
1,
1 over Y.
1 over
7.
y to
To
the
the second.
7th power.
7.
Difference is 7.
Right there.
13?
Would be 1 over z to the 20 power.
27th power?
That's what I meant.
Yeah. All right, here's what I want you to do for Monday. 1 through 1 through 19 odds.
Oh.
Yes.
1 through 19.
1 through 19 odds.
Plus 7, 9, 11, and
1 through 19 odds. Okay? And then you have page 189.
Oh,